All right, we're starting the second section. We're doing slope, and we're going to add to our distance equals rate times time problems. Do a little bit new one on that one. All right, I've got a picture in your notes. We're going to your note sheets back. We're going to go back and forth to those. We're going to your note sheets now. I've got this picture in your notes. And the question is, what is slope? Does anybody have an idea? Can you give me something about, it doesn't even have to be.
It's the slant of the line.
That's exactly right. And I even put a strange word up here, and I don't even know if it's a real one in the dictionary. It's the slantedness. How slanted something is, okay?
Adding one business would be better.
Yeah, ridiculous. Might be ridiculous. There's more than this. There's one more of these I didn't put, but we're going to be talking about 3 different kinds. There's one more that we haven't covered yet. There's a positive slope. There's a negative slope, a zero slope, and there's going to be another one in later. Positive, negative, and zero. We're going to look over there at these lines. We're always going to go from left to right when we're talking about this. From left to right. If you were an ant and you were walking on these lines and you were going from left to right, if you were walking, which one would you be walking uphill? The blue, the green, or the purple?
Blue.
The blue. The blue one is a positive slope. If you want to write the word positive on that slope, that would be fine, somewhere on there.
Ours doesn't exist.
That's right, but you can see mine. So this one right here is a positive slope. It's going uphill, and that uphill, you really have to look at it in the right direction because from left to right, it's uphill. If I was over here, going downhill, but we're not doing that. We're going from left to right, like we read books. So then that would be a positive. So what do you think the green is then? Negative. It's going downhill. And the purple one is zero slope. Zero slope. That is different than a no slope. We'll talk about that another time. It's different than a no slope. It is a zero slope. It's just a flat. All right, mathematicians, they put numbers to slopes, as you can imagine, because that's what mathematicians do. And so the ones this green one's going to have a negative value, whatever number goes with it, it'll have a negative. The blue one will have a positive number that is associated with it, and that one right there will only have one number associated with it. It will be a zero slope. All right, the next one, we have something called rise over run. This is what you'll hear for slope often. It's the rise over one. The rise is the up and down, and your run is from side to side. Rise over run. This is actually, you memorized this for Formula Madness and you didn't realize it. The rise is the difference in your y values. That's the y2 minus y1. And the run is the side to side. It is the side to side. That's your x values. That is your x2 minus x1. I've put quite a bit of space next to your notes over there so you can write some of this stuff down. What letter did we put with this, if you remember? M equals, correct? M equals. Now, when you're over here on a graph, we could find the slope of these graphs without having to add this formula. We can use this rise over run. So what we're going to do is I'm going to have you come over here to the blue, my blue one. You don't have colors on yours. But I want you to put a point where it actually crosses a nice corner of your graph. I've got one there. There's another one there. Find two. I want you to make. I want you to put a dot where it crosses the nice corners. Can you do that for me? We're going to find the slope.
Nice corners.
Okay. Like this one doesn't cross nicely on a corner, so don't put a dot there. Only put it where it crosses the corners of the graph. Okay.
It was like
Nice corner. Not a mean one. Not one of the mean ones. Now I'm going to draw a right triangle right on the lines of my grid. I like to do it down. You could have come over here on the up, but I don't know. I like the down. Then I count the boxes. How many boxes are on the up? 2. My rise, by the way. And how many are on this side here? 1. All right. If you remember.
Then you put 2 over 1.
And why did you not put 1 over 2, Isaac? Because you were correct.
2 is the y quadrant.
That's correct.
Like the y axis.
That's
and
correct.
The x is the bottom.
And we have the y on top, or the rise on top, and the run. And you could write 2 over 1 as your slope, but I would just write 2 because 2 over 1 reduces, and I don't want to write the 1. So. Let's do the same thing for the green one. Let's do that for the green one. Find two consecutive corners. 2 consecutive corners. Make your right angle. All right, so we have 1 over 1. How did he get a negative, though? Because that doesn't show a negative anywhere.
Because it's slanting.
Because it's slanting down. So this slope, that's the trick that you have to make sure you remember. Since it's slanting down, you got to put a negative. The slope is -1, because 1 divided by 1 is 1. The purple one, you just have to know that that's a slope of what?
0.
0. I'm
So
going to put an
you
M.
undefined. Wouldn't you put undefined?
Not on this
Undefined
one.
is up.
That's correct.
Undefined is up.
That's
Okay.
correct. So I haven't covered that one this time, but yes.
So M equals 0 plus 5?
Or just, not M, but Y equals 5 in that case.
I don't like
Because remember the Y equal lines are horizontal? Okay. If you remember, I just wrote that slope formula. We'll be using the slope formula to also find some slopes. And you memorized it for your Formula Madness, and I wrote it on the board just a moment ago. Let's do some examples together. Let's do numbers 1 and 5 at first. The points, I don't even have to find where they
1,
cross
7.
the nice corners for you, Brett. And then you can write the numbers if you want to count. I've got a 1 here, and he says it's 7. Please verify.
I verified.
1, 2, 3, 4, 5, 6, 7. All right. All right, is this 7 over 1 or 1 over 7?
1 over 7?
I heard 1 over 7. Is it true?
Yeah.
It is 1 over 7. So the slope, the answer is 1 over 7. If you want to put an M equals, just to keep it in your mind that this is M, because we said that slope is M. All right. Now the other one. Oh, wait. How do we know this is positive? 1 over 7.
Because it's slanting to the right.
It's slanting going
Up,
uphill
right.
from left to right. Number 5. We're skipping to 5.
-4.
I heard negative. I'm going to draw mine here. I got a 4 on this one and a 1 here. Is it 1 over 4 or 4 over 1?
4 over 1.
Negative or positive?
Negative.
Negative. I'm going to put an M equal. Questions?
Wait, wouldn't that be a -4?
Yes, it is a -4. Thank you. There we go. It's coming up there. There it is. It's there. Questions? All right, here we go. Question. 17, -4, and 6, 0, 6, 6. We're going to use that formula. If you remember, we've got, I'm going to write it at the top. M equals y2 minus y1 over x2 minus x1. And you need to decide which one you want. You want 17 minus 6 or 6 minus 17?
17 minus 6.
That's what I want to. 17 minus 6. If that's the case, since I picked 17 first, I have to pick -4 first bottom. Oh, wait, I'm doing this wrong. What am I doing wrong?
You did X on the
I'm doing X on the top. I need to do X on the bottom. 17 over 6 minus 6 on the bottom because it's X on the bottom. So maybe I don't want to do it that direction.
Yeah,
-4 minus 6. You like it that way?
I don't know how I like it. I just have it already written down.
Okay, so let's just do it.
Write it down.
Yes,
and just
okay.
do it. I really don't care.
What is -4 minus 6?
Negative
-10. -10, you're right.
And 17 minus 6?
11.
11. Leave it as a fraction. -10.
Oh, you want us to leave
Or
it as
just leave it.
fraction?
Just be
I
done.
put it in commas and stuff.
Yeah, just put it in. Just be done.
In parentheses, I mean.
All right, let's do the y first. And the y's here are the 7 and the -7 and the -15. Which one do you want to go first?
15.
The -15 first, Brett?
No, -7. It's always from
He
left
said
to right.
15, I've already written it down.
Okay, so -15.
-7 first.
Be careful. You can do that one if you want. I'm gonna go and be very careful. This is minus a -7.
So all you're doing is
Dude.
adding.
Mm-hmm.
Oh, sorry.
Since I did the -15 first, Brett did it. That way I'll be fine. What do I have to go first on the denominator?
-7.
Yes, -7 minus 14. It will not matter as long as you do it consistent. Your negative will cancel to be the right thing. This is going to become a plus. -15 plus 7 is how much?
-8.
That's correct. And -7 minus 14.
21? -21?
That's what I got. Which the two negatives cancel. For everybody else, they'll have positives when they're done. 8 over 21. Does 8 over 21 reduce?
No.
No. Now, we're going to talk about two different kind of graphs. These are on your notes. We're going back to your notes now. 2 lines that are parallel, and I have 2 lines that are perpendicular. Same colors. I've got purple and green, or blue and green, and blue and green. Let's talk about the parallel ones first. If you were to calculate these two slopes for the parallel ones, what would we get? What relationship would they have?
Same, right?
They'd have the same slopes. Notice they're going to be the same slantedness. If they're parallel, they're never going to touch. They have to have the same slopes. If you at some point want to write same slope on there, that's fine. They're going to be the same. Same M.
In math, do you use the words decline and incline when referring to this?
Sure. Decline would be the positive slopes and decline would be the negative
I was
slopes.
just wondering rather than
Yeah.
slanted.
Now, the perpendiculars are going to be a little bit different. They're not going to be the same slopes. We can at least know the relationship between one of them's going up and one's going down, right? So how does that affect the relationship?
They're opposite.
There'll be opposites. One will be positive, one will be negative. So if you knew this one was a positive 5, you could at least know this was negative something, right? Does anybody remember the relationship between these two?
Contrast? Is that what you're talking about?
If I know the slope of this one, which is, I've got a dot there and there. I know this is 3 over 1, which is 3. So the blue one is a slope of 3. You with me so far?
Mm-hmm.
Okay. Let's do the green one. This one and this one. What's its slope?
4? 2. No, 3.
It's got a 3 here, and do I do 3 over 1? 1 over 3. But it's going downhill, so it's
Negative 1/3.
negative 1/3. What's the relationship?
Is it a negative reciprocal?
It's the reciprocal, and it's negative, okay? So perpendicular slopes are the negative reciprocal. Another thing that other mathematicians like to say is if I took those two slopes, 3, and I multiplied it by negative 1/3, I would get a negative 1 as my answer. So the two slopes multiply to make negative 1. Always, always. I like the negative reciprocal part because if I know 1, I know if I knew the 3, I could find the perpendicular slope by making it a negative and taking the reciprocal. Or if I knew the negative 1/3, I'd change the negative to a positive and I'd take the reciprocal. So, number 13, is this slope positive, negative, or 0? And I even have or none. So let's talk about that none. I said that that's one thing that we hadn't covered yet. Let's talk about that none. We had 3 different lines before. We had a positive going uphill, a negative going downhill, the horizontal being the 0, so the vertical will be the no slope, all right? Is this one here positive, negative, 0, or none?
Positive.
It's positive. Okay, so now letter A, you're going to write the word positive. Letter B, what is the slope? How do I find the slope of that?
Find 2 nice points.
Find 2 nice points. Those ones that smile when you talk to them. What is that slope?
2.
2. I got that 2 also. Now they want you to draw a line that is parallel to the line on the graph. Does that mean that Natalie's going to have the same line as Nariah necessarily? No, just as long as it's parallel. So when it's parallel, what should its slope be? Its slope should be your new line that you're drawing. What should its slope be?
That way.
The same.
It should be the same. It should be 2. So if you wanted to come over and draw a line and make sure that it went down 2 and over 1, because that went down 2 and over 1, then you could make sure you had a parallel. All right, so you should have a slope of 2 on your new graph. So I've actually answered letter D. Also, you drew a line that was parallel, and you should have a slope of 2 when you're done.
That's what it is.
Okay? We're going to move to number 14 pretty soon. Letter A on number 14. Is this a positive, negative, 0, or no slope?
Negative.
Negative. What is that slope?
Let's find out.
2? Negative 1/2, sorry.
1/2.
Now I want you to draw a line that is perpendicular. I don't want to parallel this one. How are you going to do that? How are you going to draw a line that's perpendicular?
Just we.
You could do we if you want to try that. That would be fine. But what would be its slope? What would be its slope?
Reciprocal.
What is the negative reciprocal of
2?
It would be 2. So you need to draw a line. That line over there. A slope. It has to be a slope of 2. So put a dot somewhere. And how are you going to get a slope of 2?
Draw that.
You don't
Come-
draw it.
You're going to go put a dot somewhere. I'm going to do it like right there. And I'm going to come down 2 and over 1. Down 2, over 1. And if you keep going down 2 and over 1 and down 2 and over 1 and down 2 over 1, you'll have a positive slope. It'll have the negative reciprocal slope of the one you have. And it'll be perpendicular. Number 1, let's look at number 15 and 16. You're going to go way back to number 1, way back up there. This is 15, but it's referring to number 1. What is the slope of the line that is parallel to number 1? What did you get for an answer for number 1?
2.
You got it. What did you get for an answer for number 1 way back up here?
1/7.
1 over 7. So what would be the slope of the line, a line that would be parallel to that one?
Not 1/7.
I heard not 1 over 7. I heard 1 over 7. So which is it?
1/7.
There we go. Letter number 16. What is the slope of the line that is perpendicular to number 2?
-5.
So what is the slope of the line that is perpendicular? So the slope of number 2
1, 2, 3.
is 1/4, correct? So what's the perpendicular slope? The regular slope is 1/4. This is the symbol for perpendicular. It's like an upside down T. What's the perpendicular slope then? Negative 4/1, or you can just write -4. We're going to do more with this distance stuff. I am going to just do 2 problems with you, and we'll get the hang of how to do them while we do them, okay? The trick to this one is now, last time when we did distances, we had somebody was going to and back, and the distances were equal. Another time, we had people going in opposite directions, so we added their distances. Now one person is going to be ahead, and they're going to have to catch up, okay? Eugene left Scott's house and traveled toward the train station at an average speed of 40 miles an hour. I personally need to draw a picture on this. This is Eugene, and he's headed towards the train station. I'm going to put a little E for Eugene, and he's going at 30 miles an hour. Sometime later, Stephanie left, traveling the same direction at an average speed of 50 miles an hour. I'm not going to put the arrow yet for my length. I don't know how far I'm going to draw it. After traveling for 3 hours, Stephanie caught up with Eugene. What does that mean if she caught up? What does that mean their distances at that point are? They're equal. Stephanie went 50 miles an hour. And how long did it take her to catch up? 3 hours. So I don't know about the 3 yet, but just let's see here. It says, find the number of hours Eugene traveled before Stephanie caught up. So which of these am I making the T for? Eugene or Stephanie? Eugene is the T.
Because he left.
Because that's the time we're looking for. It says, find the number of hours Eugene traveled. But what is the time for Stephanie?
3 hours.
3 hours, because so I'm going to write over here, T equals 3 for her. Okay. So we know that their distances are the same. So I like to write this out. Distance of Eugene equals distance of Stephanie. I'm going to put in the place of the distances, because distance equals rate times time. So what's Eugene's rate times time? 30t. What about Stephanie's distance? It's rate times time. And
50 times 3.
50 times.
50 times 3 is what I
Very
meant
good.
when I said.
Yes.
We got you.
Can
Okay.
you put the 3 in parentheses?
You can. I can, definitely.
Thank you.
You're welcome. All right. Solve it, and I'll give me a hands up when you did it so I can kind of get an idea.
5 hours.
5 hours.
That's right. You got that H and the R up in
That's what HRS.
Where did HR from?
there. Hours.
Hours.
Mm-hmm.
Wait, we have to add that?
We do.
Yep.
Yeah, you have to put your units on there. Yes.
I mean, you can be wrong if you want to.
I got
50.
Oh, please.
And I like putting HRS because it's plural. But,
I do too.
just trying to do a little bit of grammar in there. All right. So the thing about the thing about them catching up, depending on the problem, when they do catch up, that means they did the same distance. So their distances will be equal when they catch up. The trick, though, comes with finding putting where the T goes and putting in. Sometimes one person went a little 2 hours longer or 2 hours less, and you have to add and subtract those numbers. Okay. 4. Number 24. Paul left Lisa's house and drove west. I'm going to draw that. I like to stop as I go. I'm going to go west. West is this way.
Anything from the other guy?
And I'm going to put Paul right there. Okay. Kayla left 1 hour later. I'm going to wait for that 1 hour later because I don't know which one's going to be T, because it depends on which I'm finding. Driving 7 miles an hour faster in an effort to catch up to him. After 4 hours, Kayla finally caught up.
Dang, she really want to see that guy.
What was Paul's average speed?
she
So
had.
Kayla started and then caught up, so their distances are going to be the same.
Either way, she
We don't know the rate of either one of them, but we know somebody went faster, right? So what's the variable? We want an R on somebody. R on Paul or R on Kayla?
Paul.
On Paul. And I'm going to put that here. I'm going to say that this is R because we want Paul. And then what do we want for Kayla's?
I'm watching.
7 miles
7
per
miles
hour.
per hour.
R plus 7.
10 miles an hour faster.
So it's R plus 7.
Oh, R plus
R plus 7. You ready?
Yeah.
C.
Now we have to figure out time.
4.
4 hours.
Who's 4 hours?
Cool.
Both of them.
It says after 4 hours, Kayla caught up.
No, it's Caleb
But,
got 4.
so she's 4 hours, but she left an hour later. So how long did Paul go?
5.
Yes. Yes. This makes his time be 4, and Paul's will be 5. What do we know about their distances with this?
They're equal.
Their distances are equal. So Paul's distance and Kayla's distance are equal. So we plug in for distance, we plug in rate and time, right? So Paul's distance, is going to be rate times time, which is what?
5 hours.
5.
5
and-
times R.
That's correct.
What did you get out of this?
And what about
I'm watching.
Kayla's?
Sorry.
No, it's okay. 7x plus, no, sorry.
You do 23.
That would be
4R plus 7.
Yeah, and I'm going to put the R plus 7 in parentheses. And I might have to scoot over there a little bit. I might just duplicate this. Am I allowed to duplicate it? Yes. I'm going to come over here and duplicate it right there and squish it down so I have room. Come on. There it is. Okay. Move around, find R. You guys, that's the algebra part's not a problem. We did that. That kind of stuff's algebra 1. It's setting it up's the hard part. Yeah.
no, it's
28 what?
I'm laughing at myself for doing that.
$28, 28 miles per hour.
What did you get for 23?
28 miles per
Why
hour.
are you trying so
All right, when we're doing the problems where one person is catching up with another, when they do catch up, they will have driven the same distance. That is the key, is that our distances are the same. The trick comes, though, is determining who gets the variable. The variable comes in the question. This last one, Paul had an average. We want Paul's average speed, so we want to make him have the variable, and then we add and subtract based on that to him. Okay? Questions? All right, this is what we did on this lesson. We learned about slope. We learned how to find it on a graph. We learned how to find it with two-ordered pairs. We also found relationships when they're parallel and when they're perpendicular. And then we talked about distance equals rate times time when one person needs to catch up with another. We added a new twist to our distance and rate.